Everybody is welcome to the YouTube channel. Today I want to discuss on the topics of the linked list. What is the linked list? Already we have discussed the different types of data structures, and also now we want to discuss the linked list is a linear data structures. Linked list is a data structure where we store the data, not a contiguous memory location, but separate memory location, different types of memory locations surrounding the other secondary devices. So in this way, we can store the data by using the linked list. Linked list is a data structure where each and every node represent two types, minimum two separation is there. One is data, another is pointer. Pointer for next node, and that node, that is next node, contain the pointer for the next node. In this way, each and every node is separated and is identified by the pointer of the previous node. So the linked list is always a group of the nodes. Consecutively, it is linked with each other. At the head point, it is identified by the head node, and this head node identifies the first link node, and this link node identifies the second link node, second then third link node, then the fourth link node. In this way, and the last link node, the last node of the linked list is the contain the pointer in the single linked list. No value of the pointer, that is null pointer, is defined as the last number of node, where in the case of the single linked list. So we can classify the linked list normally three ways. First is the single linked list, and second is the double linked list, third is the circular linked list. So singly, doubly, and circular linked list. Single linked list single linked list shows the pointer. Each node contains two parts. One is pointer, another is node value. And this way, and first at the first pointer, first node contain the pointer are also node value, but ahead of this node there have a head point. Head point always shows the first node of the linked list, and the last node of the linked list contain no pointer. In case of single linked list, contain the value of the pointer is null value. Of course they have a pointer, but value is null value. So linked list is a sector, linked list is a process where we can store data at not a contiguous memory location but separate memory locations. So it is a good process to link the data. But in case of single linked list, it is the last node contain pointer of the null value. In case of the double linked list means each and every node, intermediate node of this linked list have pointers, two pointers always. First pointer for the first node, second pointer for the next node. So previous node and next node. For two types of pointer is there in case of double linked list, except the head node. Except the head node, except the first node, the all other nodes contain the two pointer. In case of last node, the last node contain of course two pointer, but the null pointer is there in case of the last node of the double linked list. So each and every node of the double linked list contain two pointers, and first pointer for previous node, second pointer for the next node. Now I am coming the another linked list, that is circular linked list. Circular linked list means when the last node will arrive at the last node of the linked list, then it will point the first node. That is, it makes a circular. It means a circle, and the circle where that from the first node to last node and last node to again the first node. So this is the separation between the circular linked list and the also double linked list and the single linked list. So linked list is a process where we can store data at not a contiguous memory location but different types of memory location, and in this process we can use this plethora of location and separate types of location to accumulate them and to use as a data storage procedure. Now we want to identify how this procedure is functioning. First, it is a procedure to identify as the programming language. How this programming language is prepared for these types of the definition for these types of presenting the linked list. So linked list in the C++, we can define by, you can see my board, that how this linked list is represented in the C++ programming language. And in this way, each and every language, there have a structure procedure somewhere, there have another procedure, Python, there have some procedure to adjust, to see the, to represent the linked list. First, when we are consulting, we are sometimes to discuss with the linked list. Now, in this point, another perception, that is the array will come in. Because when any compare comes between the array and linked list, there have some procedure, there have some feasibility to compare with the two types of the data structure. Array is composed, array is associated with the contiguous memory location. When we are seeing the contiguous memory location, then array is utilized. Array is a process where we can store data at a contiguous memory location. Suppose this is the storing data sector. This is a sector of storing data, and one another byte is there to represent the array memory. First byte, second, third, fourth, etc. If I want to store any data using the array, suppose we are using the array, suppose that taking those bits, that is 1, 2, 3, 4, 5 bits. Taking the 5 bits, we are already using one array. And this is array. But when we want to search array is of course we have already discussed that the array is a memory location. Array occupies the contiguous memory location. That is, the array, like the linked list, it is not the required to access any element. For this element, we require the first node. In case of array, no first node, no second node is required, because the contiguous memory location is contiguous. First node, it is a first node, and this first node, and this first node represent the shows the second node, then third node, then fourth node, etc. So, like the linked list, no other pointer is required. Pointer is not there, not performed, what is not required to represent the next node. Array, so array is already a contiguous memory location. So this is the array, and if we search the first element, first portion, no time complexity is order of 1. And if we want to search the any other location, then amortized time complexity is order of 1. But in case of the linked list, when we are using the linked list, that is, in case of the for the searching procedure of the data searching procedure in the linked list, suppose this is a 3 node, first node from second node to third node, and this is the data, this is the pointer, data and pointer representing this. And first node represents the second node represents the third node. So, if we want to access the third node, then we have to we have to access the first node at first, and then second node, then third node. So, the time complexity is not equal this time complexity order of n. So, this is the difference of the in case of linear linked list, time complexity is normally order of n in case of any node we want to access, except the first node. Because first node giving the representation, first node giving the information of the second node giving the information of the third node. So it takes the more time to search an element, that is a middle element or last element. But in case of this node, it is already contiguous memory location. So to find out any node, it is very easily done, or that is order of time complexity is order of 1, that is very minimum time complexity. So in this memory, but it have a difference way, there are some difficulties in the array, because when we are using array, when we require more memory, more space we require to store data, then it is unable to store this data at that position, or easily it cannot be extended. easily this memory location cannot be extended. If we want to extend this array location, dynamic array is there. Dynamic array is already a helpful process to extend the memory of the array. In case of linked list, it is very easy. Linked list can extend memory because if we want to extend any node in these cases, suppose we want to extend any node and last node or beyond the last node, so we can add the node, separate node. So we have to link the last node with another separate node. This is the process in case of linked list to add any node. If it is the middle point node, then we have to cut. Suppose the middle point that is at that point, we want to enter another node. So suppose I am changing the D, C, suppose A. We want to enter one date node in between C and A. Then this is the node. So connecting this node with this node and connecting the end point of this node to this front position of the A. So this is the procedure to adjust to enter any node. And the time complexity is, of course, time complexity is order of n. In case of linked list and array, it is more difficult because if we want to adjust to enter any node or to delete any node in the array, then there should be a vacant position. Suppose we want to delete this node, there should be a vacant position. So this vacancy will be fulfilled from this point. So it will come here. If there are 1000 data, 1000 row, 1000 the column, 1000 the array documents, then they have each and every node should be shifted at the forward position. It is very costly. So this is the difficulties between the array and linked list. We can add any node at the array. We can count any node easily at the we can add any node as the linked list. Sorry, we can add any node as the linked list easily, but we can't array. We can't not adjust or enter any node in the array very easily. If we want to delete any node, this is also same process. We have to delete any node, then the vacancy will be created and the node next node will be adjusted with this vacancy. So this all will be shifted. If we want to enter any node at the array, then the same process, because the node will be shifted at rightwise. In this picture, node will be shifted rightwise and the new node will be entered as the array. In case of linked list, no problem is there. In such type of problem will not arise in the linked list, because linked list will enter a new node and this node will be adjusted the previous node. So only one, that is order of 1. Order of 1, that is the big node notation 1. So time complexity in case of enter node, the linked list very less than the array. So in this way we can discuss the array and linked list definitions and the other things, other purpose, other solution, other requirement in the linked list. Suppose when we want to any node as a linked list, we already know that any node can be adjusted, can be inserted, can be deleted in the linked list very easily. Time complexity is order of adjusting the middle point, time complexity order of n. Adjusting the first position, time complexity is order of 1. And so this is the positions of the linked list, because the linked list, some application shows the linked list is very easy. Some application on the array is very easy. So the difference is, if we want to, if we get some contiguous memory location, then array is the best process. But when any application is there that is not possible for the separate or fixed length, we require always a dynamic structure, dynamic memory space. The linked list is a very efficient in this process. But when we get some location where fixed length is very appreciated, fixed length is very easily we can manage the programming, then the array is very efficient. In these cases, in the array and linked list, the difference is some 4 and 5 difference is there. Suppose we want to represent any array at the programming language. As per different types of programming language, array can be defined at the defined at my, you can see my at my picture or at my board how array is defined in the different types of programming language. Also, we linked list, we can define linked list in case of different types of programming language differently. Now we want to see the what is the purpose of the linked list to access to introduce error as a memory structure. Purpose is very easy because it's a dynamic type. Dynamic linked list it is called. Because it is a memory structure, we can add any memory, we can release also any data, any node easily. Easily it can be introduced, easily it can be deleted. But searching procedure is most costly in case of middle element, in case of last element, it is most costly to search any element from this linked list. But in case of array, it is easily we can search any element, you can also access any element. But deletion and insertion is have a complexity in case of array more than the linked list. So the difference and also association, also there are some other something is differently it is accumulated. Now we want to discuss the application of the linked list. Linked list is applied in various cases. Suppose the languages such as the Python language, it is also mostly used, and where we want to browse repeatedly, I want to use any methods. Repeatedly, I want to use the same method, same purpose, same content. So linked list is very applicable. Linked list is very useful in these cases, browsing cases. And another types of in case of the cache memory, linked list is very useful. So linked list is very useful in some places, array is useful in some places. So it is for introduction for this for the video for the linked list. Now the next video will also already organize for the insertion and deletion of the linked list. Thank you everybody.